Okay, let's look at problem 247. This is one of the homework problems. I like this problem. It's just a nice simple problem, but it demonstrates different ways to solve it. So if you look in the solution manual or in the solutions, you'll see they do the law of triangles, law of sines, or the triangles, law of sines. Anyways, you'll find that I don't like that. It's just not how I think. It's not how I do things. And so I'm going to solve this the way I would normally solve this with components, with x, y, z components. So where do we want to look? Well, let's look here at this point C. Let's make a free body diagram about C. So at C, what is C experiencing? There's 1,200 pounds going straight down. There's some force off in this direction, and we're going to call this TBC. And this is at an angle of 20 degrees. That's just given in the problem statement right there, right? 20 degrees. And then there's some force coming back up this way. I'm exaggerating this a little bit just so we can see it better. And this is at an angle of 5 degrees. And this is going to be called TAC. Okay, so what do we have? Well, we have two unknowns. We have the two tensions unknowns. And so how I do this is I'm going to say, well, let's look at the sum of the forces in x, set them equal to 0, and the sum of the forces in y equal to 0. Okay, so let's start with x, sum of the forces in x. Well, you have the lefts equal the rights, the ups equal downs, right? So I'm going to say TAC. I want to look at this portion of it right there, right? So that's going to be TAC times sine of 5 degrees is equal to that's the left force, and that's going to equal this portion of this force, right, which is going to be TBC times cosine of 20. So I'm going to call that equation 1. Now equation 2, the sum of the forces in y. So what do we have? In y, the ups are TAC cosine of 5 degrees, and that equals the downs, which is going to be 1,200 plus TBC times sine of 20. Okay, so now we just have, I guess I'll highlight these, two equations and two unknowns. So the way I solve this is I'm going to look at the first equation. I'm going to solve that for TAC, right? So come back over here where I have a little more space. Go to equation 1, and I'm going to say TAC is equal to TBC times cosine of 20 over sine 20. And then I'm going to take that and I'm going to plug it into the second equation. So TAC cosine 5. So TAC cos of 5 is equal to, apparently I'm just writing this down again, plus 2 TBC sine 20. Well, I'm going to plug this in for this, and so I'm going to say TBC cos 20 over sine, I goofed up, this isn't 20, this is 5, because it comes from this equation right there. So sine 5, all that is TAC times cosine of 5 is equal to 1,200 plus TBC sine 20. Then you solve for what TBC is. You have one equation, one unknown, so you end up with TBC is equal to 1,200 over cosine of 20 over sine 5 cosine of 5 minus sine 20, which ends up being equal to 115.4 pounds. So TBC is 115.4 pounds. Plug that back into there, and TAC is equal to, so 115.4 times cosine of 20 over sine of 5, which is approximately 1,244 pounds. There we go. So the tension that this person is pulling with here is about 115.4, and this tension in this cable right here ends up being 1,244. So let's do a little bit of sanity check. Does that make sense? Well, okay, right off the bat. So at this point, there's two forces. There's this one pulling down, and this one has a down component. So the force up here is better be at least 1,200 or more. And basically, it's going to be the 1,200 of this plus a little bit that you're adding from over here. So 1244, sure, that sounds lovely. And 115.4 off in that direction, okay, that's reasonable. A person can maybe pull with 115 pounds of force. So it kind of passes the smell test. And so you should do that. As you do these problems, kind of make sure that they make sense. So, now, honestly, sometimes you won't have a point of reference, and so it won't mean anything to you. But at least this one, you can see that it seems in the ballpark of reasonable. It turns out that that is the right answer. So there you go.